In 1965, an unexpected collision in space led to the disintegration of two satellites, creating a cloud of nearly 500 fragments whirling around Earth at incredible speeds. This was not just an isolated event, but a precursor to a growing issue. By 2009, the situation escalated when an inactive Russian satellite collided an active commercial one, generating over 3,200 pieces of space debris. Today, the challenge is compounded by SpaceX's ambitious Starlink projects, which has already added hundreds of satellites into orbit. These events make the evolution of our outer space into a bustling orbit full of high-speed debris, threatening not only satellites but also vital global communication and weather monitoring systems. It's time to acknowledge that our footprint extends far beyond Earth's surface. So let's explore the dynamic and dangerous realm of space debris, how what goes up does not always come down, and what we can do about it.
NASA confirmed that debris from the International Space Station hit a home in Florida.
Space trash, broken satellites, or leftovers from rocket boosters, as well as junk from the space station. That's all a growing problem, they say.
Hitting home for a Michigan couple when a satellite crash landed in their backyard.
An out-of-control satellite is expected to crash back to Earth today.
Space debris, also known as space junk, encompasses fragments left behind in space, primarily from rocket materials and decommissioned satellites. These remnants vary in size, from large defunct satellites to smaller debris pieces and even paint flecks. The accumulation of space junk poses potential risks, including collisions and damage to operational satellites and spacecraft. Satellites play a critical role in modern society, supporting various activities such as space exploration, Earth observation, communication, and navigation. They provide invaluable data and facilitate commercial opportunities, contributing to advancements in various fields. However, the escalating number of space activities in recent decades has led to the emergence of a significant concern, and that is space debris.
If you're the sort to support traveling to the stars, though, there's a growing challenge in getting spacecraft into orbit and beyond. We're talking trash.
Since the advent of the space age in 1950s, thousands of rockets have been launched, leaving numerous objects in orbit around the Earth. With many of these objects still present, the risk of collision continues to grow. As humanity continues to explore space, addressing the challenge of space debris becomes increasingly crucial to ensure the sustainability of space activities and safeguarding vital satellite infrastructure.
When you're on board a spaceship, you have a constant undercurrent awareness of the ever-present risk of something hitting your spaceship and causing a leak.
Since 1961, over 560 instances of in-orbit fragmentation have been documented, with a mere 7 linked to collisions. Most of these events entail spacecraft and upper stage explosions. However, it's anticipated that collisions will increasingly contribute to space debris in the future, potentially becoming the primary source. The rate of space debris accumulation is alarming. Over 15,000 satellites have been launched since the start of space exploration, with rocket launches occurring more than 3 times per week, often deploying multiple satellites. The potential for generating more debris increases. In 2000, there were approximately 8,000 trackable pieces of debris in space, a number that surged to about 20,000 by 2019 and now nears 30,000 just 5 years later. The expansion of satellite constellations, notably driven by initiatives like SpaceX's Starlink program, significantly contributes to this proliferation. Investments in space exploration, both public and private, are on the rise. In 2020 alone, investors poured roughly $9 billion into private space endeavors. The growth extends to governmental space agencies, with at least 70 countries boosting their space budgets. Forecasts predict even more substantial investments, with proposals suggesting up to 12,000 new satellites launched annually over the next decade. All space debris originating from objects launched from Earth lingers in orbit until re-entering the atmosphere. A low Earth orbit is an orbit relatively close to Earth's surface, typically at an altitude of less than 1,000 kilometers, but possibly as low as 160 kilometers above Earth. On the other hand, a high Earth orbit is one in which the altitude at apogee exceeds that of the geosynchronous orbit, which is approximately 35,786 kilometers above sea level. Items in lower Earth orbits, typically a few hundred kilometers high, often return to the Earth relatively swiftly within a few years due to factors such as atmospheric drag. Upon re-entry, the debris encounters frictional forces from the atmosphere, causing it to burn up, typically preventing it from reaching the Earth's surface. However, satellites or debris positioned at higher orbits can persist for hundreds or even thousands of years. Space junks are also produced from collisions or anti-satellite tests conducted in orbit under certain instances.
They are two different sources that produce the same threat. Micrometeoroids are the naturally occurring objects. They come mostly from asteroids or comets, and orbital debris is the man-made.
Several countries, including the USA, China, and India, have conducted missile tests aimed at destroying their own satellites. Space junk presents a significant danger due to the high speeds at which objects orbit the Earth, typically around 10 kilometers per second, roughly 300 times faster than the maximum speed on most US highways. Even minuscule debris pieces pose threats, as collisions with larger objects at such velocities can result in severe damage. Instances of space junk causing damage are not hypothetical. In 2021, the ISS suffered damage when struck by a 2-inch piece of debris. Since 2000, the ISS has undertaken 32 maneuvers to avoid potential collisions. In 2015, astronauts were compelled to evacuate to a space capsule due to an imminent threat from approaching debris. A Chinese satellite disintegrated on March 2021 following a collision, marking the first such event since 2009.
Despite the risks associated with space debris, steps are being taken to reduce this hazard to safeguard space mission and infrastructure. Efforts to clean up space junk are underway, with the United Nations urging companies to remove their satellites from orbit within 25 years after their mission ends. However, enforcing this directive proves challenging, given the possibility of satellite failures. To address this issue, numerous companies worldwide are devising innovative solutions.
Well, let's just put our head in the sand and ignore the problem, and well, that's just a responsible way to look at the problem. You really, if you can see that debris and you can avoid that debris, you need to do everything you can to do that, because every one of those events that is a collision creates thousands of other pieces of debris that you have to track.
Space scientists have looked at different ways to tackle this problem. They've considered using a harpoon, a giant net, or magnets to grab satellites. These approaches involve retrieving defunct satellites from orbit and guiding them back into the Earth's atmosphere, where they will burn up upon re-entry. However, the laser firing method stands out because it's good at quickly removing small bits of debris from 1 centimeter to 10 centimeters. They can use lasers as the beam of energy and apply force to any object to push it into higher orbits, where there's less junk, or push the debris into the Earth's atmosphere. Also, lasers can be used to heat up the satellite and make it fall out of orbit faster. Notably, lasers can achieve these objectives without physical contact, distinguishing them as a versatile and standout solution among other methods. Also, under NASA's 2023 cost and benefit analysis of space debris removal methods, it is found that the laser system is the most cost-effective way of removing this smaller debris. There are two types of lasers, ground-based and space-based. They differ in their approach to debris removal in orbit. Ground-based lasers operate from Earth's surface and typically use powerful lasers to target and track debris in orbit. They rely on precise aiming and tracking systems to direct the laser beams toward the debris. However, they are limited by atmospheric conditions and can only target objects within line of sight. On the other hand, space-based lasers are deployed in orbit themselves, generally in higher orbits, offering greater maneuverability and flexibility in targeting debris. They can operate without atmospheric interference and have the advantage of being able to approach debris from different angles, potentially increasing the effectiveness of debris removal efforts. However, space-based lasers face challenges such as power supply, maintenance, and the risk of creating additional debris from the vaporized material.
It is crucial to consider the laser as well as other methods for removing space debris. While both ground-based and space-based technologies offer potential solutions for debris removal, international collaboration and sustained effort are essential for ensuring the long-term sustainability of space activities.
In response to the escalating issue of space debris, organizations like the United Nations Committee on the Peaceful Uses of Outer Space and the European Space Agency are collaborating to develop guidelines for space travel, satellite deorbiting, and debris removal. Hence, it's crucial to re-establish policies that will significantly contribute to the removal of space debris.
Let's continue to advocate for responsible space practice and support initiatives that addresses this pressing issue. Thank you for watching. If you enjoyed this video, please give it a thumbs up and share it with your friends. Your support helps to grow a small channel like ours. Remember to subscribe for more fascinating content on a wide range of topics. I'm Shiva Sapkota and you've been watching We and Our. See you next time.